combining all of the techniques that we've covered to solve quadratic. So if you look at our learning target here today, students will be able to select and apply. So you're going to choose which method to use. And as long as it's an adequate method to solve the quadratic, we're going to go ahead and solve it and then write its solution in simplest form. So I just want to put all of the methods in one place now that we've made it through chapter 4 and talk about when we would use each method. So thus far we've learned 4 strategies, right, for solving quadratic equations. So let's review those 4 methods, 3 of which are algebraic. So we're going to talk about what the equation looks like and when we would choose that method. And then the last one is just graphing if we want to check our answers. Or if we, I guess, don't know what else to do, then we can graph. So number 1 is the square root method. We talked about the square root method is just being able to isolate our equation. So it looks something like x squared equals a number. And we could have something that's like x minus 5 squared equals something. And we said once you get the squared piece by itself, then to undo the square, you just go ahead and square root both sides. And when you do that, it introduced a positive and a negative solution on the right-hand side. And on this case, right, cancel. If you square root both sides, it introduced that positive and negative. And then we just simplified as much as possible and continued to solve for the variable. So the question is, when do we use the square root method? Well, this is the one I always look for first. Can I just isolate the variable x? Notice in this equation, there's just one x term. 15 doesn't have an x, 69 doesn't have an x, so I can get x by itself, like we saw up here, and then I can square root both sides. Notice in this equation over here, again, there's only one x piece. So if I can get that x by itself, then I can use the square root method. Remember that standard form, I'm going to write this just up above. So standard form of the quadratic equation is the one that has the a x squared and the bx and the c. So in this case, right, there's an x squared and an x term. There's 2 pieces with variables, and this is where we got stuck and we couldn't use the square root method. So we want to use the square root method, right? And I'm going to write this over here. So when there is only one x term in the equation, okay? So in this case, again, you're just going to use the techniques you know for solving equations. So we're going to move the 15 to the left. We get negative 15 here. That cancels on the right. We get 7x squared. We add this and we end up with negative 84 on the left side. So we divide by the 7 to get the x squared by itself. Our x squared is on the right hand of the equation. Negative 84 divided by 7 is negative 12. Again, this is where we would then square root both sides of the equation. So this leaves x on its own, and remember when you square root both sides, that plus or minus comes into play. And then we simplify the radical if we can. Now this negative, remember, is going to come out and it's going to be represented with an I. So this is going to be something like plus or minus I square root 12, but then 12 itself will also break down. So we break this down to say 3 times 4. 4 breaks down to 2 and 2, and we have a group of 2's there. So the 2 gets to come out right in front of that I, and it looks like it's going to be plus or minus 2I times the square root of, and that 3 is the one that's left over without a group because we broke down the 4. So 3 goes back in. So x is now by itself. We've solved this equation. Those solutions are imaginary values, 2I times the square root of 3. Now in vertex form, it's just a similar process. So again, if I'm trying to get x by itself, I need to get rid of the things that are on this side. So I'm going to add the 19 over to this side, right, because he's a negative 19. And then this 3 is multiplying, so we'll divide by 3. So let's go ahead and do that. We're going to add the 19 to both sides of the equation. So on the left side, we have 3x plus 1 squared is equal to 54. And we're just working through this, dividing then by 3. And that leaves us with our x plus 1 squared is equal to, and we can go ahead and divide that. Important too that you notice that this x plus 1 is squared. So we want to make sure that we do the square root at this point, because the x plus 1 is inside the parentheses, so our next step is to get rid of that squared. And we have square root of 18. Again, it introduces that positive or negative solution. So x plus 1 is equal to plus or minus the square root of 18, but let's see if we can break that down. That would be 9 times 2, 3 and 3. So the 3 comes out front, leaving that 2 inside. And then we want to move the 1 over because we're trying to get x by itself, so we move the 1 over. The 1 does not have a radical with it, so it can't combine with the other term. So we'll just have x equals negative 1 plus or minus 3 square root of 2. And that's solved. So that is the square root method. When there is a middle term, so now if we look down here, notice these equations look a little bit different. In this equation, we have an n squared and an n. So notice there's two pieces with variables. Same with this one over here, we've got an x squared and an x. Those aren't going to combine. So instead, we're going to try and solve by what we call factoring. So I'm going to write over here, when there is an n and an n term. So again, I mean, a lot of times it's x squared and x, but in this case we've got n. So our first step is always to set it equal to 0. This one's already set equal to 0. That's perfect. Because what we want to do is we backwards FOIL it, right? And we write something times something equals 0. And if we know that something times something is 0, then we know that one of these solutions has to equal 0, so we find the values that would make that true. So in this case, it looks like we can split this one up. We split up the n squared, so we put an n here and an n here, right? That way if we were to multiply this, we would end up with that n squared, so we're just factoring it going backwards. We then look at the last number, 72, and we think about things that would multiply to 72 if we were to multiply the last times last. So 72 would be something like 3 and 24, 8 and 9, and we want to make sure that they add to the middle number, so 17. So if we use negative 8 and negative 9, that looks like it'll get us that 17. So we're going to put negative 8 here and negative 9. So our solutions, right, if we look at this first factor, n minus 8, well, to make that equal 0, n would have to be a positive 8, because 8 minus 8 is 0. And here would be a positive 9 as our solution. So those are our two solutions by factoring. Again, let's just walk through those steps. So first step is to set it equal to 0. We're going to move these across the equal sign or to the other side. And remember, when you do that, right, you're subtracting them over, so they're going to change signs. So we have 4x squared minus 12x minus 112 is equal to 0. We then go ahead and look for a greatest common factor, and notice all of these numbers are divisible by 4. So we're going to divide a 4 out of each of these. We get x squared minus 3x, and if we do 112 divided by 4, we get 28, and 0 divided by 4 is 0. So again, we're going to follow the same steps we did on the last one. We're going to break this up to x and x, and we look at factors of 28. So factors of 28 would be like 2 and 14, 7 and 4, and it looks like if we had a negative 7 and a positive 4, those would subtract to negative 3, but multiply to negative 28. So we want negative 7, positive 4, so when we solve this, we would say x is 7, because 7 minus 7 would be 0, and the other x would be negative 4. Okay, so again, we use factoring when there's an n squared term and an n, and also if there's a value that's like a is equal to 1. So if there's not a number out front, remember when there was a number, then we had to do bottoms up method. Now the reason we didn't have to do bottoms up method on this one is because they were all divisible by 4, so that number went away. Okay. All right, the next method is the quadratic formula. So I'm going to write the formula up here. Now remember, the quadratic formula you can use at any time. It takes a little bit longer just because we have to plug in the values. But again, if our equation is written in any of the forms. If we write it in standard form like this, we can identify that a, b, and c, and then we go ahead and solve. And we use opposite b plus or minus the square root of b squared minus 4 times a times c, and we divide all of that by 2a. So this one you can use anytime. I just want you guys to realize that you can use it anytime. But I would generally use it if the equation is not factorable. And it has an x and x squared term. So it's not factorable. We can't use the square root method. Then we'll go ahead and plug it into the quadratic formula. Remember, the steps are always, once again, to set it equal to 0 and look for a greatest common factor. That just allows us to simplify. So we're going to go ahead and subtract the 5 over. So we'll have negative 12 is equal to 0. We then look for a common divisor, and it looks like everything divides by 3. So we're going to divide it by 3. That allows us to get n squared plus 6n minus 4 is equal to 0. Now notice if I were to try and factor this, there's nothing that multiplies to 4 that has a difference of 6. So this one's not factorable. So we go ahead and identify our a value. Now the a value again is the number out front of the n squared term. So in this case it's just a 1. The b value is in front of the n term, so that would be 6. And the c value there would be negative 4. So in this case, we're going to solve for n using the formula. So we're just plugging the values into this formula here, and then we'll simplify. So we get an opposite b, or negative 6, plus or minus the square root of b squared minus 4 times a, which was 1, and c, which is negative 4, all over 2 times the a value. So in this case, we've got negative 6 plus or minus, and remember, we always start by simplifying inside the square root. So this one looks like we're going to have 36 minus 4 times 1 times negative 4 looks like 52. And then we look to see if we can break down 52, and 52 is divisible by 4. So I'm going to build a little tree here. So 4 and 13, that would be 2 and 2. So the 2 gets to sneak out front of the radical. Now again, make sure we don't put it all the way out with the 6, because that's a different term. So we're going to put a 2 there, and it looks like this 13 was left over without a group, so it stays inside the radical. And then we have a 2 on the bottom. And then our last step with this was to look at kind of our 3 coefficients. So if there's something that divides out of all 3 front numbers in all 3 terms, now we can't simplify it, right, if it's only 2 of them, but notice all of those are divisible by 2. So if I divide out a 2, that gives me negative 3 plus or minus 1, and you don't have to write the 1, but I'll write it just as a placeholder, and then like all over 1. And we don't necessarily have to write 1 if it's the only thing left on the bottom. So this would be our final answer. Okay, same idea. If we were looking at the next one, again, we could subtract this 2x over so that everything's on the same side. And again, this is the x term, so I'm going to put it in the middle to make sure that my a, b, and c values are correct. If you look at this one and we ask, is there anything that divides out of all the terms? There's not a number that divides out of 5, 2, and 7 that's greater than 1. So we just go ahead and identify our a value, which in this case is 5, our b value, which in this case is negative 2, and c, which is 7. Okay, if I'm putting this into the formula, then I do the opposite of b. If b is negative 2, I'm going to do positive 2 plus or minus the square root of negative 2 squared minus 4 times a times c. And that's all going to be divided by 2a. So we've got 2 plus or minus, again we multiply, oops, I thought that was a 15, 10 on the bottom. We go ahead and we simplify the inside. So if you look at the inside, we do negative 2 squared minus 4 times 5 times 7, and we talked about you can plug that whole thing into your calculator if you need to. And then we have this negative 136. Now notice that negative means that there's going to be an I, right? So the negative comes out as an I, and let's see if we can break down 136. So that divides by 34 and 4. So that's 2, 2, oh, not another 2. 2 times 17. So this 2 gets to come out with that I. So this is going to look like 2 plus or minus 2i times the square root of. We have a 17 left over and a 2. So we multiply those and put them back in as the 34, and it's all over 10. Once again, we look at those 3 coefficients to see if anything divides out, and it looks like they're all divisible by 2 once again. So we get 1 plus or minus 1i square root of 34. 10 divided by 2 would be 5. Awesome. Lastly, we talked about graphing as a method for solving. Remember that graphing, when should I use it? Well, you can use it anytime you want to like check your answers. So I would use it maybe to check your solutions if you're ever wondering, or if you just can't remember how to solve it algebraically. If you're given an equation that doesn't even look familiar, you could always graph this and give it a shot. If it does have an I in its algebraic answer, you won't be able to graph it or solve it by graphing in this case. But let's just go through one of these. So again, this first one, if I want to graph it, I do need to be able to put it into my calculator into the y equals function. So I need it all to be on one side. So I'm going to go ahead and move this 3x over. So notice in this case I will have x squared. Those are both x terms. So negative 3 minus 3 more is negative 6x. And then there's nothing left on that side. So in my calculator, I'm going to go ahead and go to y equals, and I'm going to put in x squared minus 6x. Let me see if I can pull this calculator up. And again, you guys could use Desmos, or if you're on your calculator here, you would just put in that x squared minus 6x, and you can go ahead and graph it. And if you graph it, you can see that those solutions there are going to be at 0. And then there's another solution over here at 6. Mine doesn't show the tick marks very well. And then you'll notice that that vertex is right there at 3, negative 9. So we could actually plot a graph of this just to kind of help us see. But we're looking again for those x-intercepts. So our solutions, it looks like it crossed at 0 and 1, 2, 3, 4, 5, 6. So I know that my solutions here are 0 and 6. So that's one way to solve. On the assignment, you are asked to finish graphing it just to practice with that. So 1, 2, 3, 4. I'll finish graphing this one. But we could plot this. Oops, that's the wrong point. And again, you can use your calculator, or you could use the table of values, right, to kind of help you draw this graph if you need more points to make it a little more accurate. So there's our function. Okay. Again, the homework is going to ask you to use a few of each of these methods and then let you choose. So